This brings us to exercise 3.2, where we will use the RMC joint loading probability toolbox to create a joint loading matrix. We will start by copying the earthquake hazard data and pasting it as values into the table under step 3 of the earthquake hazard worksheet in the toolbox. Next, copy the stage duration relationship and paste it into the table towards the bottom of the flood hazard worksheet. We are told a detailed level was used as the method for extrapolating the stage duration relationship, so we will select that option from the dropdown. On the consequences worksheet, input the day and night exposure. For this example, we are told to assume a 10-hour workday. Next, we will copy the breach and non-breach life loss from the companion spreadsheet and paste as values into the life loss table on the consequences worksheet. Next, on the risk screening worksheet, we will input the earthquake and flood thresholds that we want to consider. And then input the headwater and PGA intervals to evaluate. We were given the headwater intervals in the companion spreadsheet, so we can copy and paste those in. For the PGA, the highest PGA evaluated was 1G, so we can use the preset intervals and simply delete the accelerations greater than 1G. The headwater intervals must include a value for the defined flood threshold elevation, and the PGA intervals must include a value for the defined earthquake threshold PGA, else a warning will be displayed. Now we have our completed joint loading matrix. Assuming a system response of 1 for all coincident loadings above the set thresholds, we get an APF of 3.66 times 10 to the minus 4, as shown shaded in red at the bottom of the screen. As such, we would be unable to screen this potential failure mode out based on coincident loading alone. Assuming a system response probability of 1 for coincident loadings above the set thresholds results in an average annual life loss of 8.27 times 10 to the minus 1.